Take a quick look around you. I'm pretty sure there are different objects around. How would you describe the things around you? Big, small, red, bright, or even dull? These are properties that describe objects or phenomena. So in this lesson, we shall be talking about physical quantities and their units of measurement. In other words, how to identify physical things around us. Imagine I walk up to a seller and say, "Give me 50. Certainly his reply will be, 50 what? But when I say, "Give me 50 oranges," now that's something you can identify. Since physics is the study of our physical environment, it is important to identify or measure our physical environment properly. For example, looking around your environment, you will want to know, how big is my house? How far is my school from my house? Or even, how long will it take to walk from my house to my school? To help us properly understand this and more physical quantities, scientists and engineers around the world came up with a system to measure and identify physical quantities. There are two systems of measurements, namely the International System of Units, also known as the SI units, and the Imperial System. The SI units are also called the metric system, and this is the most used system of measurement in the world. Using the SI units of measurement, I can say the distance from my house to my school is 2,000 meters. What this means is 2,000 is the value and meters is the SI unit. This is life made easy, right? All physical quantities are divided into two categories, namely fundamental and derived quantities. Fundamental quantities are the independables. In other words, they don't need any help in determining their identity. Examples of fundamental quantities are time, mass, and length. Let's take time for example. All you need to measure time is a time measuring device such as a clock or a watch. You don't even need a formula for this. Quite easy, I think. Derived quantities, on the other hand, are the dependables. These quantities are dependent on other quantities to properly identify them. Examples of derived quantities are acceleration, volume, and density. Let's take density for instance. To find the density of a substance, you need to find the mass of that substance, then you find the volume of that same substance, and divide the mass by the volume. As you can see, density depends on the quantities, mass, and length, since volume is also a derived quantity dependent on length. Truly, these guys are dependable. In our next lesson, we shall be discussing more on the dependables and the independables. Bye for now.